morning. This talk is about music. Actually, it's about listening to music, to be precise. And I will start right on with a little test to you to see how well you do. Two sound examples. And the question to you is, do you hear a difference? This is the first sound. And this is the second. You hear a difference? The first is a German baby. Much to my surprise as well. And the second is a French baby. This is research by, I give credits all lecture through on the bottom right, by researchers from Germany and France who interpret this as the first steps in the development of language. The French average intonation pattern is up. The German average intonation pattern is downward. These babies have already hearing in the last 3 months of the pregnancy, and they pick up these intonation patterns from the environment and imitate it in their crying. I think there is actually much more to be said, that this is actually evidence for a musical skill. And that will be my argument throughout this presentation. I think there's now more and more evidence, and I will show some examples, that very young babies and infants have actually very strong musical skills in contour perception, in rhythm perception, in picking up dynamics, actually the building blocks of music. They use these musical skills much later on, like 6-7-month-olds, to maybe to differ between word boundaries. So they use it for language much later on, but I think you can argue that from the beginning on, these are really musical, skilled listeners. And that's the main argument I want to... Oh, you hear? That's what babies do, they keep on crying. But differently. We all share a predisposition for the perception and appreciation of music. That's my claim. There might be skeptical people in the audience here that say, well, I have this neighbor or I have this friend. I have a test for that. We know a lot now that people that claim that they are not musical. I have a little test here as well. Let's do it. 2 short melodies, and the question is again, are they the same or are they different? Is it same or different from this one? Who's in doubt? The estimates are roughly 4% of the population has this particular deficit, which is called amusia, not being able to pick up the differences between melodies. It's a very special talent, but those people are indeed unmusical in this particular definition. There's a lot of research done. We know not precisely yet which brain areas are involved, but there are localized roughly here as marked in this particular diagram, where the size of the circles indicate the location, but also the amount of evidence that's there that this particular function is located over there. More than 50% in this case. But you have to realize that they're actually part of whole networks, these particular functions, in this case, the functions of the perception of melodies. If you look at listening in general, you get a much broader picture. You see that all these different functions have different locations and are actually spread out around the whole brain. So virtually our whole brain is involved in listening, showing that our brain has an intimate relationship with music. I don't want to spend too much time on the brain, but go back to my main question is like, what now defines musicality? What makes us musical animals? What are the mechanisms that you need for that, to appreciate music? I have another example here, without sound. And my question, I'm going to ask one person in the audience to maybe sing it for us. Who is willing? Who's willing to sing it? There's a microphone in the hall, I hope, somewhere. Is there? There's a microphone. Who wants to sing it for us? Well, thank you very much. I think we do another one. Take your time, huh?
I think the song is written for me.
Take your time, yeah?
Okay, I'll try.
Ha 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 ha, staying alive, staying alive. Ha 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 ha, staying alive.
Very good, thank you. Remember the pitch and the tempo. This is the original. What a lot of my colleagues have shown is that actually what this skill is actually what you could call absolute pitch. People remember the pitches almost perfectly of songs that they know very well. They also remember the tempo very well, and that makes this song very popular for heart, how do you call it? Somebody with a heart failure. This is the right tempo, 103 beats per minute. That's why the title is sort of applicable. So my point here to make is that absolute pitch, so remembering the pitch of a song, and then maybe knowing that this song starts with a C, then you have this skill that musicians say is a very special musical listening skill. My claim is that it is not very musical at all, and it is actually something we share with lots of animals. For a bird, a melody that you play slightly higher is a completely different melody. And that's relative pitch. That's the thing, one of the skills I think that you need to be musical. Relative pitch, recognizing a tune. I sing a tune, you recognize that it was a children's song or something like that. Let's go into relative pitch a little bit more. Again, a sound example with a question to you, is this the same song or not? But this time the second melody is slightly transposed up, but you have to judge whether they are the same melodies. Who says different? Virtually all. Another one. Who says same? Who says different? 50-50. We're replicating here a classic experiment in music cognition. They were all three different. If you present these melodies to infants of 6 months old, they hear these differences easy. The second one was just one note higher, and the last one was, I think, 4 semitones higher. If you present this to adults, they make this 50-50 mistake with the last example. It's actually evidence that you as a listener, not passively listening to the music, but you project all your history of listening to it. You actually project the whole Western harmony on this particular example, and therefore some people didn't notice the difference. There was 4 semitones difference, but it fits in the harmony. You expect a certain harmonic progression to occur, and that fits in there so you don't notice the difference. So you as a listener are active, you're musical, and you influence your own perception of music. And that's also the fun of listening to music. So these are examples to show to you that absolute pitch is actually very common. Relative pitch, what we think is trivial or can be thought of as trivial, is very special in that sense and fundamental for appreciating music. In the rhythm domain, because we talked about melody right now, in the rhythm domain you have a similar dichotomy, like opposition. Sense of rhythm is something you see through the whole animal world, monkeys that can drum or do rhythmic behaviors. But what is actually very special is what we call beat induction, or maatgevoel in Dutch. The sense of sort of picking up the regularity from music. It's argued to be a fundamental skill. If you can pick up the regularity from the music, you can't make music together. You can't dance together. So it's a fundamental skill that allows for music, or even can be argued is conditional to music. Until recently, the idea was that this beat induction is a thing that is learned. Your parents rock their babies to the rhythm or dance their children to the rhythm, and that's how they figure out where the beat is. We did an experiment in Amsterdam in collaboration with Budapest with newborns to see if they have beat induction, whether they have a sense of beat. I have to warn you, these pictures look a bit awkward, but they are not. These are 2-day-old babies. They have just been fed, and they're sleeping. They have a number of electrodes stick to their head. We measure the EEG on the skull, and they have these open headphones, and they're listening to a drum rhythm while asleep. And they listen to this particular rhythm, and I want you to sort of listen to that rhythm and sort of count how many gaps or syncopations you hear in this particular rhythm. And yeah, here it is. Who counted 2 gaps? Majority. Who counted 5 gaps? 2, 3, 4. There were 5 gaps. But our minds, all these gaps have the same physical length. They're as silent as the other rests. We call them loud rests. And there are loud rests, the 2 gaps, because we have a high expectation something will happen. Our expectation is violated, and therefore this rest is sort of occurring to us as being very loud. And that's an index we used for sort of probing whether somebody has beat induction or has this sensitivity for regularity in music. And that's what we measured in these newborns. And we see exactly on these silences that were loud, or that were highly expected, we see a peak in the brain signal. The red line, you see this mismatched activity. And we don't see it for the other rests. So this was evidence that newborns to 3-day-olds already have this musical skill of beat induction. It is not learned, apparently. Well, this was very exciting for us, and it sort of changed my whole research in a way that, yeah, I now want to know, yeah, when did this develop? What is the evolutionary story that makes us, does this really mean that we're all sort of ready for music? And where did it came from? With which animals do we share this? And that's more recent research that our group, but also a few colleagues in Europe and North America are doing. And sort of seeing, like, comparing humans with other animals and see how they share these fundamental skills, relative pitch and beat induction. Surprisingly, there are actually 2 surprises. Great apes, they show rhythmic behavior, but you can't have them synchronized to the music. It's impossible. Somebody tried for a year to learn a monkey to do that, and it didn't work out. Surprising. Second surprise is that a completely, or at least evolutionary scene, for us, a remote species, appears to have beat induction as well. This is a celebrity cockatoo now. It's called Snowball, and he apparently is able to pick up the beat and dance to it. You see him at the left there.
Brothers, sisters, everybody say.
Well, this is very exciting for cognitive biologists, because now we have to explain this co-evolution. There might be 2 reasons why we humans and birds and other focal learners, actually is the current hypothesis, share this beat induction. I'm still skeptical about this bird, but also about this hypothesis, because I expect, monkeys, we have more often sort of thought that we are very different from monkeys, and most of the time we turn out to be more similar. So that's why currently we're doing the same experiments we did with the newborns, we do now with rhesus monkeys in a collaboration with a group in Mexico, where a neurobiological institute is expert on in this field. And we're doing the same experiment, and this is my cliffhanger in my last 50 seconds. We don't have results as yet. It is too early. And it's a good thing to first convince your peers and then convince the general audience. But independent of the outcome, I think it will help us in sort of filling in this puzzle. Like, where are the origins of music? Where did they arise in the history of our species? I hope that I have convinced you, at least, that what makes you musical are 2 very trivial things. Relative pitch, recognizing a melody, and beat induction, tapping your foot to the music. Those are very special musical skills, and those skills are what makes us musical animals. Thank you for your attention.